So we saw in our last video just an overview of the approach to teaching young children science. Our goal is to get them to learn how to think and not just to give them facts and have them memorize them. Our major overall goal is to, at this stage, get them interested in science and to allow them to start exploring based on their natural curiosity and their natural ability to learn, to ask questions. So we said that we have, as teachers, we have our learning outcome in mind when we go in the classroom, and then we plan activities around that learning outcome that are geared toward having the students to be interactive with the content, with the activity, to ask questions, and in the end, we guide them toward the main learning outcome while still allowing them to develop their own cognitive skills, to still be able to develop their processes of questioning and processing data and thinking critically. So we looked at the 6E method. So now we're going to move into the second lesson in this module. We looked at each component of the 6E instructional model. And basically reminded ourselves that we do still want to teach kids to think systematically using the scientific method. We want to help them to be able to develop into citizens of the world who are critical thinkers, who can actually separate data and fact from opinion. Our last major point was that we're not trying to teach them pure science in elementary school. We want them to gain a curiosity of what scientists do and to learn how to learn how science knowledge is developed and to have a way to participate in constructing their own curiosity and view of science. Now, in the next lesson, we're going to look at how science can be discovered through inquiry. Now, we just reviewed basically what the inquiry approach was. It is seen as a way of teaching and learning about science that reflects how science is performed by scientists on a daily basis, which is the process of asking questions, looking at data, looking at facts, going back, thinking, and asking questions again. It's not teaching the kids what to think, it's teaching them how to think. And I know you're tired of me saying that, but that's the basic takeaway that we had in the last lesson. Inquiry, as the textbook states, is a paradigm that is used by both scientists and students. So when we hear about paradigm shifts, a paradigm is basically a viewpoint. It kind of like gives us how we view things, our viewpoint. A paradigm shift is a way of shifting that viewpoint. So basically, if we think, okay, if our viewpoint is that the sun is the center of the universe, and then later scientific knowledge tells us, our new facts, our new data tells us, no, 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 the earth is the center of the universe, then that would be a shift in the way of thinking, a paradigm shift. Now, paradigm shifts occur because scientists continually ask new questions and continually do new experiments and come up with new technologies to better explain what we observe in science. And sometimes we end up with the paradigm shift that is a revolution in the scientific community because scientists used, you know, their ability to think critically and the process of uncovering new scientific knowledge. Okay, the NSCS authors, they say that a successful science classroom is one where the students and the teachers are collaborating in the new pursuit of ideas. And sometimes the students are actually engaged enough that they can initiate new activities when they're doing an inquiry activity in your classroom. So the instructor's role is to guide that activity and interact and intervene with the student as often as necessary in order to promote the learning objective, but to still allow the student to to ask the questions and to perform the activity to gain his or her version of their own understanding, to develop their process of understanding, because we still want them to end up with the knowledge that is the goal of the required learning outcome, but we want them to be able to develop their own method of understanding science. And reminding ourselves that our goal in inquiry is to facilitate the learning and not make every child into a future scientist, but to produce a society that is literate in science, that has a basic understanding of science principles. So you basically want them to be scientifically literate. We want them to have scientific literacy. And that means that the person can ask, find, or determine answers to questions that are derived from curiosity about everyday experiences. As a nation, we will have the ability to meaningfully participate in societal growth through making informed decisions, proficiently engage in work that will support economic productivity and knowledge and understanding of scientific concepts to make informed personal decisions. Now, this is very important. If we like we mentioned in the last video, if we think about the political discourse, the social issues, there are a lot of things out there that our country is facing in terms of challenges that could very easily be solved if more of our citizens were scientifically literate. However, global warming is one of those issues. A lot of things are subjected to personal opinion and political commentary, and the masses, the public at large, in many cases, are not as abreast or as cognizant of the real scientific issues, because in many cases, even our political leaders are not scientifically literate. So we really need our students, our children, to grow up into adults who have the ability, the basic ability, to think critically and to ask the right questions, to understand how to separate fact from scientific data, fact from opinion, etc., to help them to make informed personal decisions in their own lives, and personal decisions in terms of how they can vote or influence the well-being of society as a whole. Now, the constructive approach to learning, constructivism basically is belief that we don't just pass on knowledge from the teacher to the student, but the knowledge is constructed by an individual as he or she creates his or her own worldview. The student may replace a prior belief about a science concept, add to their existing knowledge, or modify something that they already know. So, learning or concept construction takes place in the context of what the learner already has in his or her mental store. So, basically, it's highly individualized for each student. So, basically, we want to help them to construct their knowledge by facilitating the learning process as opposed to transferring knowledge. The instructors is expected to facilitate this learning process and to provide the materials that the student needs to help him or her individually get the best learning possible, to make the process of learning individually meaningful for every student. So, to this end, constructivism is a student centered approach. Student centered is one of those other buzzwords that we'll see a lot. Students centered, peer learning, inquiry, all of those are basically ways to say that we use activities to help the student develop his or her own understanding of the material. And so, according to your textbook, everyday classroom events can be used to transition into an inquiry activity and help and have the class develop an experiment of some sort. That would be an example of a constructivist, student-centered approach to learning, to to have the students develop an experiment in the classroom together. Another example of constructivism or student-centered learning, or also the inquiry method, is peer tutoring. Peer tutoring, when a high achieving student tutors a lower achieving student. And that helps to basically reinforce the knowledge of the higher achieving student and help him or her to be able to expand their knowledge by helping the lower achieving student, who then has an opportunity to interact with a peer and ask the questions that's necessary for him or her to expand their knowledge as well. That is an example of how culture and society play a role in mental development. That kids don't simply reproduce what is said or shown to them, they undergo socially mediated cognitive construction. So basically, they construct their knowledge based on what's socially occurring around them. And to have peers tutoring and participating and developing experiments together helps to facilitate this social construct. And so, as these functions, according to the theory of Vygotsky, is that mental functions begin on a social plane. So basically, in the surroundings of the student, and then they're able to internalize what they see or hear or are learning. And we have to also be aware that the context, the perspective that the students bring into the classroom are definitely going to be affected, are definitely going to be framed by their social experiences outside the classroom. So, what lifestyle that they're leading, what are their realities? What are they seeing outside their classrooms at home? What are they seeing on television? Basically, it's all the framework for the context that the student will have when they begin to process their internalization of the scientific knowledge. So, the zone of proximal development. This refers to the difference of what a learner can do with help and what a learner can do without help. Because we know that, students are, they can learn on their own, but with the intervention of a teacher or a group, then the student can learn exponentially more as the teacher acts as a scaffold to come in and help to provide the scaffolding or the framework to guide the student to the desired learning outcome. And while that is occurring, the student's level of development and level of learning will increase exponentially, both to accomplish the stated learning objective and beyond. So we talked about in the last video, we talked about the importance of teaching students teamwork at an early age. And collaboration is essential in a functional society, and collaboration in the classroom provides the basic foundation for allowing that child to learn the fundamental interworkings of how society works and how people interact together to accomplish large goals and to solve challenges. It's a method of moving from lower learning to higher learning. And basically, it's the system by which activities within a child's zone of proximal development are successful. So, science instruction should be a model of how science is performed by scientists, which is through collaborating with colleagues. So basically, we've been saying over and over again that we're not just basically teaching them a whole bunch of scientific facts at this point, but getting them to understand the scientific process and understanding them to think like scientists and be able to put facts together and interpret data, et cetera, et cetera. Well, at this stage, the collaboration that they can get in the classroom setting by working in a group, working with their peers, peer activities, et cetera, collaborating with their colleagues. This is basically just like scientists do on a regular basis. They take what they know, they go out and they collaborate with others and they pool that knowledge. And as a result, the knowledge of each individual scientist is exponentially increased, and the whole of the body of knowledge increases because as people collaborate, they tend to, in addition to the facts that they already have, they ask more questions, and then they're able to add to what's already known. And so collaboration is a very important component of a scientist's approach. And at this young age, even if a child never becomes a scientist, introducing them to collaboration with his group, with his peers, with his the groups of students around him will help him not only in the pursuit of scientific knowledge in the future, but also to help him learn other subjects as well. The textbook that I'm referencing suggests that there is a top down approach to the language that is encountered in science and how students are able to internalize it. So basically, if we surround the students in the elementary classroom with lots of books that have stories about the scientific content that we're trying to get them to understand, and then later from that whole be able to go in and pull out specific vocabulary in context of those whole stories, then it will be much more it'll be much easier for the student to understand the vocabulary in this way rather than just saying, okay, these are your vocabulary words for science out of context. So basically, if we just give them a list of words and say, memorize these are the definitions, that is much less effective than providing the students a story that has a context within that story. We can pull out vocabulary words that the student will be able to much more easily identify with the words based on the context that has been provided in that story. I know that might sound a little bit redundant what I just said, but basically, we don't want to just give them stuff to memorize. Is what I'm saying. We want them to be able to paint a big picture of what these things actually mean. So, after activity periods, it's pretty important for the teacher to ask open-ended questions to see how much the student has been able to process and retain. And so we're back to looking at our 6E instructional model, which promotes the inquiry-based learning in the science classroom. And when we saw in the first video, which was chapter 1 in that book that we're looking at, the 6E model involves engagement, exploration, explanation, elaboration, evaluation, and e-learning. And so if you need a refresher on the individual descriptions of each one of these components to the 6E model, I encourage you to go back to that video and rewatch that. So now our next chapter or step is to plan for inquiry. Now that we've got an idea of how students best learn, we know the basic components of the 6E model. And so now how do we actually go and plan the activities that we need to take this into the classroom? And so in order to do that, we can use the three-step backward design model that's described in your chapter. And it has three stages. The first is to understand what are our desired results, what will be our assessment evidence, and what will be our learning plan. Now, these three steps work very well in synergy with the 6E model. Okay, so in phase one, the desired results stage of planning provides the basis for determining what students will know and be able to do as a part of the lesson. A teacher must first look at their state's academic standards and benchmarks to make sure that they're choosing activities that are appropriate. Once a benchmark is chosen, a teacher should determine what is the big picture understanding, essential questions, and potential misconceptions that are related to this benchmark. So, understand what big picture understandings the student should have, what are the essential questions, and what are potential misconceptions related to the benchmark. Phase two is assessment evidence. Assessment methods should be matched to the desired results. So, our desired outcomes should actually determine what assessment method that we use. So, based on what you want your student to learn, then we can create assessment criteria. These can be in the form of rubrics, self assessments, homework assignments, etc., and they all should be geared to help the teachers to check the students' understanding of the material from the original desired learning outcome. Okay, so now that we've determined what our results are, what we want our students to know and learn, what skills or concepts that we expect for them to learn, then we've also determined what evidence what assessment we're going to do for the students as evidence to see how much they were able to learn during the activity or form the outcome. Now we need to plan the activities. So now we need to design a learning plan. And this will be done implementing the phases of the 6E model that are the engage, explore, explain, and elaborate with appropriate e-learning opportunities. So we've determined our learning outcome, we've determined how we're going to assess whether or not they've learned it, and now we need to plan the activity, the inquiry-based activity to engage the students, allow them to explore, help them to be able to explain what they know, help them to elaborate, and then to supplement the lesson with the appropriate e-learning opportunities. So, from the student's perspective, which class would you rather be in? One where the teacher is at the front of the room giving a lecture that is about leaves, and the teacher has a picture of a whole bunch of different leaves, and she describes the different leaves using new vocabulary? Or would you rather be in a class where the students are working in a group, they're sorting out leaves that they collected as they walked outside, they picked them up, and now they're sorting them out. And the teacher helps to guide the students to grouping the leaves correctly, and then as she does that, introduces new vocabulary. Which one do you think would be more engaging and more interesting to a student? To sit there and listen to words as pictures of leaves are being displayed, or to be able to go outside, pick up a few leaves on his or her own, bring them back inside, sort them out as the teacher guides them through, showing them new vocabulary words based on, okay, this is what this leaf is, this is what this leaf is. And then they're able to actually connect with the content. Which class do you think would be more engaging? Which one would, as a child, which one do you think you would rather be in? So, in conclusion of this module, as we saw in the last example, inquiry is a much more effective approach than the traditional approach. It's much more engaging for the students. It captures their attention, and it's much more effective at getting them to actually reach desired learning outcomes. Again, we see in this chapter that that is what our main goal of elementary science education is. Not a robust set of scientific facts, but promoting inquiry and getting them to interact with their surroundings and learn by in the process. When we plan for inquiry, teachers must consider the desired result, what evidence we will use to assess whether or not the desired result has been accomplished, and they also must consider the learning plan that integrates the 6E model. Then that we're going to talk about quite a bit as we go forward. So the next couple of modules are going to cover or talk about inquiry and assessment. Okay, so remember that we're trying to teach our kids to think and not merely to remember. And we're also trying to teach them how to learn. And so we want them to understand how to do this individually and as a part of a team. This gives the student an individual sense of responsibility for their learning. And so many times, this is where some alternative assessment methods like portfolios are put in practice in many successful teachers' classrooms. These alternative assessments allow us to demonstrate understandings, skill development, and attitudes to others, and also define learning goals and track achievements for ourselves. What we really want to get out of the assessment process is improved learning for the student. It is to improve the student's opportunity to learn and to make sure that they're able to construct their knowledge, their skills, and their attitudes. In terms of the 6E model, assessment is a critical part. The E is for evaluation. It's a critical part of this module. It places assessment in the overall context of the learning cycle and not solely as a one-time activity that occurs after teaching on a topic. So assessment is an ongoing process that is done continually throughout the activity. There should be opportunities for self-assessment, informal assessment, and a formal assessment. Okay, just as I just said, rather than giving a test at the end of each chapter in the book, assessment should be ongoing. An assessment can occur through any phase in the 6E model. For example, in the engagement phase, when students are first exploring a topic, The teacher can even assess their learning at that point by walking around the classroom and observing. They can assess the student's prior level of knowledge, what the student brings into the activity, what they already have formed, and what they're learning now, and what they're adding on to that learning. Teachers can ask probing questions to check for further understanding, such as if we're talking about the leaf demonstration that we just talked about a few minutes ago, what do you notice about the leaf? So to see how the students are forming their thought processes and connecting with the learning outcomes. In the ongoing assessment process, as the teacher uses the multiple methods to systematically gather data about student understanding and ability, they should analyze that data to guide their teaching. They should guide the students in learning how to assess themselves to figure out what they know and how they're learning. And they should use student data, their observations when they teach, and they should use interactions with colleagues to help to reflect on and improve their own teaching practices. So, ongoing assessment not only is to determine, is to assess the students, but also to allow the teacher some opportunity for self reflection to be able to assess their methods of teaching and potentially to improve their teaching practices. In using this data to collaborate with trusted colleagues to try to learn better and more effective methods for teaching, as well as using the data to interact with policymakers and principals and school board or whoever it is that affects the policies that relate to student education, to be able to take this data to be able to help to improve the learning process for students at home with their parents, in the community, or the educational processes in your school district, etc., as a whole. Okay, so we saw the backward design principle in the previous module. And so we said that we predetermine the desired outcome, determine the assessment methods, and then plan the inquiry activity. Now, when we predetermine our goals, then we can have a better opportunity to focus our instruction because now we know how to engage our students for exploration, explanation, and elaboration parts of the 6E model. It's been said that the American curriculum is a mile wide and an inch deep. So, having a goal in mind helps us to be able to get into deeper and more connected learning with our students. It helps them to be able to go more deep into individual concepts rather than the teacher standing in front of them and just quickly skimming over the basics of certain concepts. Okay, so the National Science Educational Standards suggest that when we assess our students, that we should assess what is most highly valued. So we instead of what's most easily measured. So we want to assess what's most important in terms of what it is that is most important for the students to know, not just something that we can easily measure. In other words, we have to take our assessment to make sure that we're getting to the core of what the students are actually retaining and understanding and what their reasoning processes are rather than just giving them a sheet of paper and saying, here's your test at the end of a chapter. We want to be able to, at this stage, to assess their ability for reasoning and to see what they understand, how they're understanding it. And this may not be a very easy or straightforward assessment traditionally. So that's why we have to have some alternative and innovative assessment methods in order to get to the core of what the students are able to understand and how they're able to reason. Authentic assessment is measuring or testing what the students really know about a concept or skill. as opposed to testing something inconsistent to what was taught or to the goals of the program. It should reflect understanding and not memorization. Authentically, we want to assess what we taught them. What was the goal of the program? Be consistent in what was actually taught to the student when you try to develop when you develop your methods for assessment. So, what are authentic assessment practices? Well, here are some examples. Examples of authentic assessment practices include assessment. Examples of authentic assessment practices are student observations, having the student to observe something and report about it, student interviews, written reports of journals, portfolios, performance measurements, of course, concept maps, attitude surveys, creative assessments, multiple choice tests, short answer tests, essay tests, and projects and laboratory experiments. And don't worry, we're just listing these right now. We're going to come back and actually look at each individual one of these, the most important ones, and provide some more details on how to actually incorporate that assessment practice and what it is and how it works and all that good stuff. So we've got two different basic types of assessment, the internal and the external. So the purpose of the internal assessment is to help us to judge or to gauge what the student's learning is, to guide our learning and instruction, and to classify and select students depending upon their performance. External assessment is administered to provide information for accountability, policy decisions. So basically, these are like our standardized tests. They classify people for admissions into programs, to certify them for whether or not they're going to gain a certification or to hire them. So this is the assessment that results from achievement, placement, or certification tests. So what are characteristics of good assessment? It should be what they call reflective and not reflexive. It should not be an automatic end of the chapter reflex. It should be an everyday experience that is increasingly done that is virtually indistinguishable from the classroom learning activities themselves. It should be so incorporated into the classroom activities that it can't really be, the students don't know that they're being evaluated or assessed. So it should be reflective and not reflexive. When it's used to improve the schools as a whole, the term collaborative inquiry is sometimes used to describe the bridge between the data collected and the improved student learning. So sometimes schools, in order to assess their whole programs, they do collaborative inquiry and they take the data to improve the student learning overall. So we always want to be integrating assessment to improve our student learning outcomes, not just at the end of some big activity like end of the chapter. I always want to be consistently assessing, and I guess I've said that enough. Okay, so assessment data actually helps both the teacher and the students reflect on what they have or have not learned. It also helps the teacher reflect on what future lessons or activities will assist in helping the student to better understand the concepts as they're taught. Assessment data and its appraisal of learning and its role in helping us to appraise student learning should actually account for students' individual differences in varied experiences. So as we assess the students, we have to always keep in mind and accounting, making sure that these assessment methods actually account for individual differences in our students and their varied experiences. So, as we mentioned earlier, we were going to go through individually and look at the types of assessment separately and give a brief explanation of what they are and how they can be implemented. And here these are. We're going to look at essay items, performance-based assessments, project-based science, peer or individual assessments, interviews, journals, portfolios, concept maps, and teacher observation. An essay is a very essay type question or is a useful tool in evaluating whether the students can actually express the personal ideas clearly. It can be designed to assess higher order thinking, the student's ability to solve problems, or the student's capability to reason about the relationship between different concepts. An essay can be subjective, however, and when we're grading our essays, we should design a rubric to provide a fair and consistent method when grading these items, because different students will have different, once again, different experiences. So basically, their linguistic skills and all those things may be better one to the other. They will be. There will be differences in those, and so if we can design a good rubric, then that will provide a way for us to make sure that we have a fair and consistent method to be able to actually grade the content knowledge that the student is describing, rather than just subjectively looking at their style or their writing style, etc. Okay, so our questions must carefully be designed. We want to look at these examples. Instead of what are the phases of the moon, we would design a question that would go beyond just the names of the phases and require the students to provide an explanation of why these phases occur and what they would look like. So, an alternative essay question would be explain what we would observe here on Earth as the moon goes through its phases. Explain why it appears this way to us. So, it makes sure that we can assess the student's higher order understanding of moon phases rather than just saying, what are the phases of the moon? Just listing them out. Okay, so now let's look at a performance-based assessment, which is know and be able to do. Because students are doing something, we can assess the procedure as well as the product. If we ask a child to measure several irregularly shaped rocks to find the one with the greatest volume, that's an example of this. So some teachers actually feel that when we have hands-on and minds-on science programs, when we are actually observing the students and interacting with them as they're going through their activities, that this actually provides enough assessment data. With earlier grades, especially observing these types of activities, observing the students as they perform the activities is the primary means that we gather the assessment data. When we're observing students like this, we have to make sure that we don't include any bias because, sometimes we have our favorite picks or whatever. This is so-and-so's child, et cetera, et cetera. We have to make sure that we are excluding all of those potential biases in our evaluation. And to do that, a teacher should have a checklist of what skills should be demonstrated by each child. So when we design a performance-based assessment, there are 3 basic steps to follow. The first one is to construct the performance task for the students. After you determine the desired outcome that you want the student to achieve, determine what it is you want the student to know, construct a performance task for the student, and then brainstorm ideas and develop a task description. This is often done as a group effort, but it can also be completed individually. And then you actually write a task question. And so write something that you're going to give to the student, write out the question, and present it to the student. What is it that we expect them to be able to do? Okay. Assessment of the performance of the task can be done through teacher observation, through student interviews, written outlines for the student to fill in, or daily journal entries. Okay, now let's look at project-based science. So, project-based science actually allows a student to investigate a question based on a scientific phenomena. They are able to engage in exploring important and meaningful questions through investigation and collaboration, and this can be done in small groups or as individuals. To design a good project, it has to have a few components. From first of all, from start to finish of the project, there always should be there will always be self-assessment. So each, from start to finish, after each step, a self-assessment should be continually ongoing. So components of a good project are the title of the project, what is the problem, the materials, the hypothesis, the experiment. And so then we're going to actually, from the experiment, we're going to generate our data, results, conclusion, and then we're going to have basically what were the results of the overall. You have your data and results from your actual question, but now we're going to put it in context in terms of the overall problem. So the research results, communication of the investigation follows. So when we assess a project, we want to look at, are the parts of the report or presentation logical and consistent? Does the display of the model show evidence that the student has actually learned? Is there evidence that the child overcame any difficulties or was successful at problem solving in this project? Was the child resourceful in substituting materials as needed if something was missing? And does the child or other children ask further questions based on the project? For peer or individual assessments, let's look at that. So students can actually be involved in the assessment process themselves by designing creative and authentic assessment procedures. Student-created assessments should be low stake, meaning that they should be only a part of the overall assessment package. And they must be given clear directions so that the students understand what is required from the assessment. So this actually enables them to be an integral part of the assessment process, and it helps them also to have an elevated cognitive engagement with the material. So we just said that a peer-based assessment method was low stake. So let's look at the difference between low stake and high stake. A low stake assessment is a tool to assist in finding out what a student knows, in determining future curricula, or in diagnosing a student's skills. A high stakes assessment is used to determine passing or failing, to determine whether a student will be placed in remedial or advanced programs, or to decide on graduation, to compare students, classrooms, states, or nations, etc. So low stakes is actually on the ground to determine what individual skills they're learning, what he knows, determining how we're going to guide the curriculum. But high stakes is basically the future of the student, the nation, or whoever it is that we're comparing. Interviews, okay? So interviews as an assessment method provide an effective way for us to be able to clearly get information about what the student knows. It's particularly useful for younger kids who really can't write, and also it's good for students with with special needs. To perform the interview, the other students can do the interview or adults, but make sure that there is a list of questions to guide the interview. Make sure that when we give the interview, we don't intimidate the child. We want to sit at his or her level and use their name and tell them what you're doing. If the student wants to be illustrative, to create an illustration or model, that should be allowed in the interview process. So for an interview, there are some ways that we can prompt discussion. These are some leaders to help us to be able to get the discussion started. And these are, tell me about something, such and such. What do you think about such and such? How do you feel about such and such? Can you explain why such and such? Describe how you would such and such, or how did you discover such and such? To maintain the discussion, to keep it going after the initial prompting of the discussion, other questions that can be asked are things like, what else can you say about such and such? What if you were to such and such? How is this related to such and such? Is there another way to explain such and such? How could we change such and such? What questions should I ask the next student about? So those are um, some interview questions to maintain the discussion, to keep it going. Okay, journals as assessment methods. A journal can help a student to record, to observe, to outline procedures, drafting hypotheses, developing inferences, writing results of experiments, or just simply reflecting on what they've done. A journal can actually be a place where they record the processes or simply to reflect. When we have a scientific project, we will be required recording scientific data in a notebook or a log is usually necessary to record these observations over time. Okay, it offers the opportunity to improve science learning and to practice important writing skills at the same time. And in addition to this, you can incorporate creative writing by asking the student to write a story about outer space using vocabulary that they've just learned, for example. So journals can be used to simply collect data in a logical and organized fashion, to provide reflection on what they've just done, and they can be used for creative writing where we can give them a context and some vocabulary words and ask them to create a story to incorporate those words, incorporate what they've just learned. Portfolio. Portfolios are really cool, I think. A portfolio is a container of evidence of someone's knowledge, skills, and dispositions. We can have artifacts such as a student's stories, lab reports, pictures in a portfolio, and we can have different kinds of portfolios. We can have a graduation portfolio, grade level portfolio, project portfolio, portfolios that are graded, portfolios that are integrated with different concepts. We can have cooperative group portfolios that are integrated with other students. We can have multi-year portfolios that span the years, multiple intelligence portfolios, portfolios of intelligent behavior, class profile portfolios, school profile portfolios, time capsule portfolios, just etc., etc., etc. They're so versatile. So what goes in a portfolio? So both the student and the teacher should select items for the portfolio. The teacher should say, the student should say why they chose each artifact for the portfolio. I'm so sorry, excuse me. Okay, excuse me. Okay, in order for us to have diverse portfolios, then these portfolios will be reflective of diverse learning opportunities in the classroom. So in their portfolios, they can put artifacts such as tests at the end of a lesson, at the end of a unit, performance activity log pages, project or book reports, concept maps, other graphic organizers, charts, graphs, science journal pages, creative stories, science words learned, artwork, out of class assignments. I don't know why I'm choking. Probably because I'm reading all this stuff out of this paragraph so fast. Okay, sorry. Videotaped resources and data, cartoons and analysis or explanation. So there are so many things the student can put in a portfolio, And the diversity or the depth that a student will be able to use in such a portfolio will depend on the teacher and the types of learning opportunities and the diversity of those learning opportunities that are provided in the classroom. Okay, so in a portfolio, everything that goes in, every artifact must be dated. E-portfolios or electronic portfolios are very neat. They're very convenient because they're stored in the cloud or on a hard drive or on a disk. So there's a reduced amount of paperwork that's necessary. A portfolio will, since it is a collection of artifacts over time, it will actually guide the student to look for improvements in their work. It will guide the student to, ask questions about how do I feel, what do I feel good about, and what do I want to improve. So looking at all of this stuff allows the student to be able to say, I need to improve this, or I'm doing pretty good about this. And it helps them to be able to participate in their own self-evaluation or self-assessment. Parents can assist in evaluating the portfolio and help develop a better teacher-parent, teacher-child, and parent-child communication. So this portfolio is a very powerful tool. Okay, now let's look at concept maps. Research shows that organization and meaning go together. The concept map is probably the most used organizer to help children construct meaningful relationships among the facts and concepts that they learn. An effective small group project is a concept map. It can be used as such because communication and negotiation among members helps in identifying student misunderstanding. So in a concept map, we have terms such as nodes, which are the specific locations where concepts contained in the map are occurred, and links or cross links that are the relationships between concepts in different nodes of the concept map. Propositions are the connecting of words such as has, can be, is, or part of. And what I'm going to do, since this text-based explanation is not, I don't think it's not quite as helpful to understand what a concept map is versus actually seeing one. I'm going to try to put some links up for you on Blackboard that show what each one of these things looks like. Okay, so in terms of teacher observations, we can observe and often help students to stay on track in whole class settings, but the most productive times are likely to be when we are in small group or individual situations. And that it provides us with the opportunity to quickly find out whether students understand the concepts and processes. And we can do that by being in a small group or individually with them, to ask them questions and to listen carefully to their responses. So we want to be able to provide opportunities for that to occur, provide opportunities, facilitate situations where we can be able to individually interact with students or small groups, to ask them questions to find out how they understand the processes and concepts being taught. And we want to be able to carefully listen to them to see what it is that they're missing. Okay, and in this observation, we can form follow-up questions in these responses that we get from our students. This may help us to be able to detect the misconceptions and quickly address the errors in our students' thinking. An open-ended question has more than one correct response or pathway to a response. And it's not a yes-no question. So if we give an open-ended question, that allows for more than one correct response. And these are very useful in identifying misconceptions or in promoting a student to think divergently. Okay. An example of an open-ended question would be, what happens to the respiratory and circulation system when a person is playing football? Okay. So this series of modules has helped us. This last module has helped us to understand some good methods of assessment, some ways that we can actually assess our students' learning. What I will ask you to do is to research. What I just gave you was an overview of some of the most effective assessment methods, especially the concept map, the e-portfolio, and the projects. I will ask you to go and look for additional information on these methods. I'm going to try to find a few for you and post them along with this information here. But it would be very useful for you to Google or look on YouTube for examples of science projects in inquiry based learning for elementary students, for you to look up concept maps as assessment methods for elementary students. Also, to look up ePortfolio as an assessment method for elementary science students. And that will give you a good visual to be able to connect, just like the younger kids. A lot of us are visual learners and we need to be hands-on and integrative as well. So I know that I'm throwing a lot of text-based information at you in a lecture style, the same lecture style that I'm telling you not to give your students. But I want us to be able to go out and look at some of these more closely, and that way you get a better idea of how it can actually be used in the classroom. So I'm going to go ahead and stop the last module here, and we will pick up in the next one. This is give you an opportunity to go ahead and start answering some of your questions and etc. And I will see you in the next module.